Right. Let's stop talking, guys. We're in section 4.4, and we're going to talk about CPCTC. All right, so what we've done so far in chapter 4 is we've figured out several different ways to show that triangles are congruent. So we know that we can show triangles are congruent by, we have a bunch of ways to show triangles congruent. Side, side, side. And these are the things that we put on our graphic organizer. Side, angle, side. Angle, side, angle. Angle, angle, side. And hypotenuse, leg. So we have all of these 5 different ways that we can figure out that triangles are congruent. What we're going to do today is kind of link this back to what we did at the very beginning of the chapter, where we said if that polygons are congruent tells us that all the corresponding parts are congruent. So if we know that 2 triangles are congruent, on all of these we only know 3 things. Here we know 3 sides. Here we know a side, an angle, and a side. But if the triangles are congruent, all the matching parts have to be congruent. So we're going to show that triangles are congruent and then use that to figure out things about the other matching parts. And that's where CPCTC comes in. CPCTC means corresponding parts of congruent triangles are congruent. So that's why we write CPCTC. So the idea of using CPCTC is that once we know that the triangles are congruent, then we can say all the matching parts are congruent. So sometimes we're interested in the matching parts, but they don't have to necessarily have to do with the side, 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 or the side, angle, side. But once we know the triangles are congruent, then all the rest of the parts we know that match up have to be congruent. So that's what we're going to do today. So all I want to do is go through a couple of proofs showing how we use CPCTC. And the proofs are like what we did on our worksheet yesterday. We figure out what parts are congruent, how can we tell that the triangles are congruent, and then once we know the triangles are congruent, then we can say, now we know all the matching parts are congruent. Okay, we good? Okay. So we're going to do a couple of proofs today. Because we're in math class, we don't believe anything unless it's proven. Yes? No one likes proofs? All right, so for this one, we're given that segment MP and segment NQ bisect each other at point O. And we want to prove that segment MN is congruent to segment QP. So let's write our statement and our reason. We'll do a 2-column proof. And here's our plan. I'm going to show that the triangles are congruent. Show the triangles are congruent. And then, once I know the triangles are congruent, then I can use CPCTC. So when we use CPCTC, we always have to show that the triangles are congruent first, and then we could say, that tells us all the other matching parts are congruent. All right, so let's figure out what we know here. We need to get some congruent parts to show these triangles are congruent. So is there anything here that we can say are congruent? We need some sides, we need some angles, we need something. M, N? No, that's what we're trying to prove. We don't know that they're congruent, we try to show that they're congruent. Yes? We know those two angles are congruent because they're vertical angles. So angle MON is congruent to angle QOP. And Carolyn says that's because they are vertical. All right, that's one piece that we know. So we have an angle. Now let's look at our givens here. MN and NQ, MP and NQ bisect each other. What does that tell us at point O? What does that tell us about this segment and this segment? They have to be the same length. That's what bisect means, right? So that's congruent to that. And NQ is bisected at point O as well. What does that tell us about these two? They're congruent. So there we mark those. That looks a little better. Now it looks like we can figure something out. So I'm going to say segment MO is congruent to segment OP, and segment NO is congruent to segment OQ. And what would be our reason there? The definition of bisect is cut in half. So I'm going to say definition of bisect. Bisect means cut it into two congruent pieces. All right. Can we say two triangles are congruent now? Do we have enough information? Yeah, we have a side, an angle, and a side. So I'm going to say triangle MON is congruent to triangle. So which triangle is MON going to be congruent to? Let's try it. QOP. That tells me that segment MO is congruent to segment QO. Is that right? No? So what do we have to do? POQ. Let's try that one. So that says MO is congruent to PO. That says OQ is congruent to ON. Is that right? Okay, now we're good. We have to make sure we match everything up in the right order. What would be our reason here? So read the congruent parts in order as you go around the triangle. Side, angle, side. Now we know the two triangles are congruent, so all the matching parts, all the corresponding parts have to be congruent. So we can say MN is congruent to segment QP by CPCTC. We have to know the triangles are congruent before we use CPCTC. The triangles have to be congruent before we use CPCTC. Because this C and CT and CPCTC means congruent triangles. So triangles have to be congruent. All right, questions there? All right, let's do one more. These are the only notes for today. So this one's a lot like our opener. So hopefully we're a little bit familiar with this one. I'm going to call this TRSU. And we're given guys, RS, segment RS congruent to segment UT, and that segment RT is congruent to segment SU. And we want to prove that angle T is congruent to angle S. We want to show those two angles are congruent. So our plan again, show that the triangles are congruent, then use CPCTC. So here's our statement and our reason. All right, let's start with our givens this time, because that tells us two pieces that we need to show our triangles are congruent, right? So I'm going to say RS congruent to segment UT, and RT is congruent to segment SU, and our reason there is given. Is there anything else here that we can figure out? Any other parts of triangles that we can figure out are congruent? RU is congruent to RU, and I'll mark that. Let me do that in red, just because that's what we figured that out. We didn't know that to begin with. And what's our reason when we say things are congruent to itself? Do you remember what that is, Fabian? When a reason when things are congruent to themselves? Starts with an R. You're almost there. Reflexive. Reflexive property. Now can we say some triangles are congruent? Do we have enough information? Yeah. Just three sides? Yeah. Is that enough? So I'm going to say triangle RUT. Congruent to what triangle? U. What was it, Danny? URS. So let's make sure. Segment RU, segment equal to segment UR. Yes? Segment UT. Let me write that over here. Say triangle RUT congruent to triangle RUS. RU and RU are fine. This says UT is congruent to US. UT is not congruent to US. Those two sides don't match up. All right, so let's double check here. UT, is UT congruent to RS? Yes, so we're good. And what's our reason here? What are our congruent parts? Read them in order as we go along the triangle. Side, side, side. And now we can say angle T congruent to angle S. So that's what we were trying to prove, is that this angle is congruent to this angle, and our reason, CPCTC. All right, questions there? So the first part is just like what we did yesterday. We're just adding on that extra piece, CPCTC. And let me tell you a story about proofs. If you kiss proofs, they'll turn into a prince or a princess, and they'll be your boyfriend or girlfriend for the rest of your life. It's true. All right, our homework page. All right, there you go.